Hi everyone, thank you very much for coming. So I'm about to talk about CLAP. So first, what is CLAP? CLAP stands for Clever Audio Plugin. It's a C interface to make a plugin, so you can talk between plugins and the AW. It was released 80 months ago, and here you get all the details to check out more info about CLAP. So first question is, why should you use CLAP? Well, because it's modern, it's simple, robust, and extendable. I've been working for UE. I've been doing the Linux part of their plugin. I've been working for Bitwig as well, and I have the experience and the vision of both sides, from the plugin and the host. And because of that, I think I could make the best compromise, and also we have such a great community, lots of review, discussion to really find the best possible interface. So I'm really proud of the interface itself. And I have to say that the documentation is very clear, precise. It tells you on which thread you're supposed to execute a function, what is the state requirements, what are the valid arguments. It tries to be as strict and to define a contract as well as possible. The license is MIT, so it's very easy to use, very simple. I come again to it. And we also have a collection of tools and helpers to help you to build a good and robust plugin. And it's open, and it's a fun project. People joining, they enjoy it. You can also participate. We have extensions to CLAP that have been proposed by random people, and they've been merged because they were good. So it's really something open that you can push new ideas to, and we are receptive. So from simple to universal. I think it's very important because CLAP is a C interface. It means that it's very easily used in other projects. Whatever your project is using as a language, be C++, Rust, Delphi, Zig, this actually happens. It will work for you. But even if you are doing a background job for offline rendering, you want to clean up some sounds before publishing them, you want to do a research project or AI something, you can also bind it to C#, to Python or anything for those tasks. It will work as well. Because it's C, it also works on all CPU architectures. It works on all operating systems. It works everywhere. And the MIT license means that it's uncomplicated. If you are a small company, then you won't need a lawyer to make sure that everything is fine and you're not doing anything wrong. But if you're a big company, it means that your legal department will also enjoy CLAP because it's MIT. And there are some business opportunities that you may have. For instance, going into a video game, into a car, or into some background cloud processing or something. And the MIT license will make everything easier to do. One very important aspect of CLAP, and one that is it will contribute highly to have robust plugin, which is the C++ glue layer that we have and the contract programming. So as I said, the documentation is very clear and precise. It documents what state you must be in and so on. And we have a C++ set of helpers classes that will do the glue between the low-level C interface and the high-level functions that you want to just override some virtual method. And in between, there is a configurable layer of checkings. So it will check for you, are you on the correct thread? If you are not, it will notify you. You can configure how it will tell you. It can crash the application, so there is no way you don't notice a mistake. But it can also just log something and continue. You can have, when you're debugging, a very high level of checking. So it will check for if you get a parameter change, that the parameter actually exists, the parameter ID exists, the value is in range, and so on. It will catch everything like that. Also, if you call back into the host and give incorrect information, it will tell you how you're giving incorrect parameter ID to the host. And catching all of that immediately makes it for a good plugin when you release, because it's not the customer that tells you, oh, by the way, it doesn't work. Like you catch it earlier. And just to give you an example, the other day, I realized that in Bitwig, we might be sometimes calling get latency on the plugin while the plugin wasn't activated. So it was pointless, because if the plugin is not activated, you don't know the sample rate, so you cannot get the latency in samples. It does not mean anything. So what I did just after that, I did add a check into this glue layer that if get latency is called, then we make sure that the plugin is already activated. And if it's not, then you will get an error reported that you're doing something wrong. So this glue layer is gathering all the experience that we have, both from plugins, from hosts. We find something, we try to put in it, and it's a collective runtime test suite, if I can say so. The process loop. So in Clap, we have an easy process loop for plugins. So it's just one input and one output event queue. Like parameter change, there are events. It's a little bit like if you receive a MIDI CC, it's one event. So you handle that exactly the same way. We have full MIDI and MIDI2 events. So you can get MIDI CC as just an event that input, you can output events. We have multiple also not dialects. So your plugin can say, I want to talk using MIDI MP, MIDI1, the Clap native not dialect, MIDI2. It can be very interesting if you make an hardware device, you want to embed some DSP, but you have like MIDI2 input and output, and you want to wrap that into a host. Clap is modern. So we have a fast plugin scanning. Why is it fast? It's because when we open the shared library, we don't need to create a plugin instance to scan and to acquire the metadata from the plugin. We just ask for a little descriptor that provides all the plugin metadata, so we can scan like thousands of plugins in no time. We have polyphonic parameter modulation. So you know in Bitwig we have this modulation system, which means that we can send this to the plugin, and even when our LFO is moving, the parameter itself doesn't move on the plugin. And you can take your cutoff and still hear the Bitwig LFO moving, and it doesn't change the state of your plugin also. We have the host thread pool. So this lets the plugin reuse the host thread pool instead of, if you want to compute many voices in parallel, for instance, you will create your own thread pool by default. And if you have hundreds of plugins creating 32 threads each, then you have lots of threads, and all adds concurrency onto your operating system with the preemption, and it kills your performance. This host thread pools gives a good performance boost. We have ARA support. We have preset discovery, remote controllers, and parameter indication. I think this one is such a strong feature that we added to Clap. It lets the host index all the plugin all the presets from the plugin in their native format, extract the metadata. It asks the plugin to give the metadata for each preset files. And then in Bitwig, you can type Diva, bass, and you see all the presets that are bass for Diva. And with the remote controls, you get the remote controls for any controller with the bank of 8 parameters. So you can have like this nice integration. And with parameter indication, you can tell the plugin, oh, you have a physical knob that is currently being mapped to that control. So you can indicate in your GUI that one knob is being controlled by a physical control as well. And this put together gives you a very nice integration for making hardware. We have also surround, ambisonic, and more to come. Now I want to talk about the libraries and tools. So if you have a Juice plugin already, it's really easy to get Clap support. You just have to add this repository as a submodule. There are some instructions, so you need to modify a little bit your build system. But it's basically adding an extension to Juice, so you get like a Clap plugin out of your code already. So it takes just a few hours to get it done. Within a few hours, you get a Clap plugin already. Clap wrapper. This is one project that is growing, and it means that if you implement clap, you can get VST3 out of your clap plugin. This is completed, and this has been implemented by people that knows VST3 very well, and it's very likely that you get a better implementation of VST3 by implementing clap and using the clap wrapper than by implementing VST3 yourself. We also have AU version 2 that is almost completed, should be completed by the end of the year. And AU version 3 is in the work. We also have a validator, so that's a tool that just tells you if your plugin is correct, doing some certain things right. I think it also can do some fuzzing on certain things. And as a summary, I want you to remember that clap is universal. Whatever project you are working on, you will ever be able to put clap in it. It will work regardless of your language, regardless of your license restrictions, and so on. It's modern. It's been released 18 months ago. It's built on top of all the experience that we have. And it's successful. It's been released 18 months ago, but yet there is so many plugins already that I lost the count of number of plugins that are there. And all the developer feedback that I got so far is, oh, I love clap, it's great, I'm very happy to work on it. Working on clap is a good engineering moment, like it's a fun moment that you will have. So this is the feedback that I had so far. So this presentation was very high level. I don't know how much time I've left. I think I was very fast. And I can show you some code if you want, or I can answer some questions. Some code. Let's go. So I have this one. Do you see it?
Should we open a window?
Okay. So let's close this one. Now. Okay. So maybe I will start with the clap helpers because I think this is the most important thing for us. This is what will make us have good plugins that are safe and so on. You remember what I said with the latency? Maybe I make it bigger. Like this. So this is the entry point from the C function, clap latency gate. You will see that you get we get this plugin, so we get back this pointer from that. Then we call ensure main thread. So we are already checking that you only call get latency on the main thread. If not, this will be caught. Then we check for the checking level. So this is like a parameter, a template parameter. So it's a compile time thing. If you set checking level to none, this goes away. So you can still make fast plugins for release, and you can, while developing, you should set it to maximal. If we are not active, then we'll say host misbehaving. So in clap, we have an extension called the logging extension. So you can log through the extension rather than just printing to the terminal. And there are a bunch of severities. And there are two interesting severities. One is host is misbehaving, and the other one is plugin is misbehaving. And when you report that, in Bitwig, if you have the right config.json, you will have like a notification with the message. So you can see immediately, oh, I'm doing something wrong. And if then you have this misbehavior handler, and one of them is terminate. So if anything goes wrong, it terminates the app immediately. You will notice it. I hope you notice it. So yeah, this is how it works for how we check everything. There are functions that checks a lot. This one doesn't check so much. And at the same time, we have like this class when you have the plugin and you want to call back into the host. We have this little class that gives you all the various callbacks. And at the same time, I don't know if you want to say mark dirty. McDirty will also do some checks. It will check that you are on the right thread, and then it will fall back forward the arguments. But those two interfaces, they really are here to make a robust plugin and to find problems early rather than later. Now that I've made my point with this one, I want to show you, let's start with the beginning. So when you make a clap plugin, you have this entry point called clap entry. And if I look at that, what it is actually a pointer to a factory. So you have your clap version here, you have init, deinit, and then you have get factory. So a factory is identified by a string. We have many factories, one for creating plugins, one for creating the preset discoveries, things that you need. We might have another one soon for like plugin state conversion. So if you want to, and plugins, so let's go now to the plugin factory here. Is it here? Oh, yeah. Yeah, plugin factory. So this is the plugin factory here. It's identified by a string. So everything is identified by a string. The plugin ID is a string like this. You're supposed to put it in reverse order, like com.ui.diva. And once you get the void pointer, you cast it to the factory. You can query how many plugins do you have. You can get the plugin descriptor. So this should be very, very fast. Like it says, no user input. It's just retrieving like constant data in your plugin, ideally. And then you can create a plugin instance. And if you look what a plugin is, like a plugin has its own pointer data, init method, destroy method. So one other thing is that in Clap, we've designed the interface so you don't have resource management. You won't pass a pointer that is allocated on the heap and so on. It doesn't exist. Like the resource management there is nothing. We managed to do the interface like this. So it's super safe to use. And this is the only resource management, if I can say, that you have in Clap. It's to destroy the plugins that you've created. You have this activation, the activation, start processing, blah, blah, blah. Here there are two things that are interesting. One is get extension. So you can get like an extension from the plugin. And the other one is the process. So first I want to look with you at the extension. And I want to tell you about the thread pool one, because it's a very easy example. So you see that an extension is described by a string like this. And often when you have an extension, you have two parts that need to talk together. There is the plugin and there is the host. So this is the case. So the plugin implemented extension is clap plugin thread pool. And the host one is clap host thread pool. And how this one works, as it says, you are on the audio thread, and at some point you have, let's say, 7 voices to compute. So you tell the host, I request an execution for 7 tasks. Then the host will, in his thread pool, call exec. It gives you the plugin back and the task index. So it will call it 7 times with the task index 0, 1, 2, 3, up to 6. And at the end, when everything is done, this function will return. So that's how it's done to use the host thread pool to process your voice in parallel. So now you have an idea of how the extensions mechanism is working. And I want to show you the process status and processing. First thing is that when the plugin process, it returns a status at the end. So it can be error, something wrong happened. Continue, it means that the plugin knows that it has, for example, some audio in its delay buffer and so on, and it wants to continue processing, so the host shouldn't send the plugin to sleep. It can tell you continue if not quiet, so the host will detect for you if you can go to sleep or not based on your output level. It can be tail, if you have a VST3 plugin and you're using this tail information, so you don't want to make it complicated to do your part, you can use that. And the other one is sleep. You know that you have nothing else to do, you can just go to sleep. So, and then comes this struct, which is the argument of the process. So you have the steady time. If you have, for example, an oscillator and you want to simulate that it is free running, and you've been sent to sleep, then you wake up, you can figure out how many samples you have slept, and then you can calculate the phase increment of your oscillator and so on. You know how many frames you have to process. You have the transport information for the at sample 0, and you can see that it's called clap event transport. So the transport is an event itself. This one is here for convenience, but you can also have a transport event in the middle of the block. For example, if there is a jump that is a little bit complicated or anything, you can have a transport event at the middle of the block. You have your audio buffers, and then inputs and outputs events. Now I want to take a quick look at how the events they are done. So you have a header for the event. So an event is a continuous chunk of memory. You have the header like this at the beginning, and once you figure out what the type of the event is, you cast that pointer to the type of the event. So you can see like, it has a size, time, space ID, type, and flags. Space ID, you may not be familiar with it. We have the core event space. So this is for the events that we define within CLAP itself, that are common for everyone. But let's say you make a special application for between the plugin and the host, and you want to create your own kind of events. Then you can register a new event space that is identified by a string, and you will be able to use that to use custom events. And you have, for one space, you will have like 16 bits to define your event types. And what does an event look like? It's very easy. It's like we have a not event that is something familiar. We have all the not expressions things. Let's find something interesting. This is interesting. We have the clap event param value, and under param modulation, they are very similar. So here we pass the parameter ID, and we also pass a cookie. Why it's interesting? Because if we just pass the parameter ID, you might have to some complicated code to find your parameter state later on. While we are scanning the parameters, you could give us a cookie that is your own. It's internal. And this cookie, it will help you to get your parameter state very quicker later on. So this makes the operation or retrieving your parameter data constant, like O1, very fast operation. Then when we target an event parameter value, if the parameter is said to be polyphonic, then it can be matched. When you have a synthesizer that is polyphonic, you have a set of voice, right? And each voice may have its own copy of the parameter state. And then we send this parameter value, and this is like a matching thing. We say, okay, match this not ID. If it's -1, then it matches everything. Match this port index. So when you declare your plugin, you can have many port inputs. Match this channel. So for instance, you could decide to send an event that matches all nodes that have been started on a given channel, but nothing else. You just put -1 here, -1 here. You put the channel info and -1 here. So this is like a matching set of data. And here you have the value. Yes, I have to stop. 5 minutes, okay. We have the parameter modulation, and there is one interesting concept that I want to tell you now. I just want to show it to you that you have full MIDI. So when I say you have full MIDI, it means that you get this MIDI event, and you get the raw MIDI data, and you get the raw MIDI2 data as well. So you have really like full MIDI. One thing that is interesting and that is worth explaining is when we have these polyphonic modulations happening from Bitwig to the plugin, it means that we need to have voice also ourselves for the LFO and so on. So we cannot like have hundreds and hundreds of voice running forever. So here there is a cooperative behavior between the plugin and the host. We have an extension called voice info. So the plugin is telling the host, I have, by the way, 16 voice that is running. And then when we start a voice on Bitwig, we start with not on and so on. We start a voice on ourselves for having the LFO. And when the voice ends on the plugin sends us an event not ended. So the voice actually terminated, and then we can stop in Bitwig our own voice for the LFO. Sorry, do you have questions? What?
We don't have a great deal of time for questions, I'm afraid. But
I'll try to be quick. Awesome work, thanks. I think there's a lot to unpack. I love the extensions idea because I think, I don't know if you were to my talk yesterday, but I mentioned there's a lot of things we would like to build, and I'm sure it's the case for everyone, that we can't build today with existing plugin formats. And this can, I think, is half of the way of solving it. Do you have any strategy to avoid extensions, like basically every plugin developer creating their own extensions and then fighting for those to be implemented in DAWs, and then trying to explain to user, yeah, it's Clap, but we need this extension for it to work, and this DAW doesn't have this extension and all of that?
Yeah, I don't see it so much as a problem. I can say that we have an open development thing, so anyone can join, can make a pull request. If the extension is really useful, I don't see why not we won't take it. Like if it's useful, if it's well designed, well documented, we are likely to take it. If it's your own extension, nobody wants it. It's your own problem. I don't. Yeah. Yes.
Thank you. This may actually be an extension to this previous question. So just in general, what is kind of the governance process you have put in place? And so, for example, say the extension question, I've been part of the OpenGLES working group at some point in the past, right? And there was definitely a very structured process around how these extensions, either vendor-specific or multi-vendor, would come to life and even be part of, say, validation and verification of the standards.
So far it worked very easily. It's just that we have this GitHub structure. People want to make an extension. They do this GitHub pull request. We have a Discord server that we keep mostly for developers because it's very technical, but anyone is welcome. And we discuss things just simply like that. If it's good, we take it. If like somebody fails to show that the extension is interesting or it's too specific, you can also have extensions that you keep for yourself. For example, ARA, they have their own extension for their companion API to Clap, but they host the extension on their GitHub repositories. So nothing prevents you from making an extension that you host yourself if it's not accepted by Clap. So this is for the first question. And I think the governance is very open today. It's we really have like lots of code review. And the change, I don't merge anything into the main branch if I don't get enough approval from other people from the community, and it's really something based upon merits, because we have open source contributors that are not part of any company in the music industry, and they've proven themselves to be excellent, so we listen to them. So if they find that something is not good, we discuss it, we try to find the best solution always. It's not complicated, really.
Okay, we have run out of time for the questions. Alexandre said he will be here to answer more questions if you're here in person. If, for the online attendees, is there any way that they can get in touch with you?
yes, they can jump on. We have this discussion thing in GitHub. We also have this Discord channel that is a little bit more private, but we open it to developers. So make a topic in the GitHub channel, GitHub project, and we discuss. We invite you, and it works like that.
Okay. Thanks very much. Big hand for Alexandre.
Thank you.